13, Section 1, forming new substances. Let's get right into it. Alright, so in the fall, you know that you see beautiful changes taking place when the leaves turn colors. You see bright oranges and yellow that have been hidden by green all summer. So the question is, what causes this change? To answer this question, you need to know what causes leaves to turn colors. Green leaves are green because they contain a green pigment called chlorophyll. During the spring and summer, the leaves have a large amount of chlorophyll in them, but in the fall, when the temperature drops and there are only a few hours of sunlight, and the chlorophyll breaks down to form new substances that have no color. The green chlorophyll is no longer present to hide the other pigments. And now you can see the oranges and yellows that were present all along. So this is kind of bringing us into what chemical reactions are. Chemical reactions are one or more substances that undergo a change to produce one or more different substances. Now, there is a lot of evidence that can tell us a chemical reaction is happening. But first, let's take a quick look at this video.
Oh.
Why do leaves change color in fall?
Leaves contain various colored pigments like orange, yellow, green, etc. But among all these pigments, only green-colored pigment called chlorophyll traps sunlight and helps leaves prepare food. Now, since green-colored chlorophyll has such an important function, the amount of chlorophyll is much higher in leaves, causing them to usually appear green.
No, they're black! Oops, I'm wearing sunglasses!
Now, during autumn or fall, there is not enough sunlight for chlorophyll to trap. As a result, leaves are not able to prepare much food. Hence, the plant begins to shed its leaves instead of wasting energy on their maintenance. However, before shedding, the plant absorbs required nutrients from the leaves and breaks down chlorophyll. Now, since chlorophyll is broken down, other pigments in leaves become visible, resulting in the change of color.
Okay, so as we said, there are a lot of evidence of chemical reactions. For example, color change. Color change might indicate that a chemical reaction is happening, although there are some exceptions. For instance, dyeing Easter egg would not be a chemical reaction. That would just be a physical change. Or if we spray painted our bike or table, that would just be a physical change. We are just changing the color. But if you have a substance that totally changes color, that could indicate a chemical change. So we would have to have a couple more clues to help us decide. Another thing that could happen is you could have a solid forming, and a solid forming would actually be a precipitate. So what is precipitate? Precipitate is a solid that is produced as a result of a chemical reaction in a solution. Sometimes when you have two chemicals reacting, also bubble forming could indicate a chemical reaction. Heat or flame produced could indicate a chemical reaction. Heat being absorbed. In other words, energy change. Now, even though the signs that we look for to see if a reaction took place, they're good signals of the chemical reaction. But they don't always guarantee that a reaction is actually happening. For example, gas can be given off when a liquid boils, but this example is a physical change, not a chemical one, because we are just changing the state. So how can you be sure that a chemical reaction is occurring? The most important signs is the formation of new substances that have different properties. So let's look at this example right here. C6H22O11 is going to be cane sugar, or a typical sugar that you have in your kitchen. Now, if you expose sugar to sulfuric acid, we're going to get the result of a carbon and water vapor being produced. Let's watch this quick video that showed exactly what just happened in this equation. If we get a chance, we might do it in class, but it's really messy and it's hard to dispose of. So let's look at this video. We are in the demo lab with Lonnie, where he's going to mix cane sugar and sulfuric acid. So sugar is a carbon compound. Sulfuric acid is a strongly dehydrating agent, so it will remove water from the sugar. When you remove water from sugar, what is left behind is essentially just elemental carbon. So the mixture of sugar and sulfuric acid will produce black elemental carbon in a rather dramatic fashion. Let's watch as Loni mixes these two compounds. Here is the sulfuric acid being mixed with the sugar, forming a slurry. You can see the reaction beginning. You will add a little bit more sulfuric acid and you can already see black carbon beginning to form. This reaction is fairly exothermic, so it will proceed with the expansion of the forming carbon to form a rapid expansion of a long snake of black carbon. That's what happened. There we have the formation of elemental carbon by the dehydration of sugar with sulfuric acid. Okay, so the starting materials in the reaction were sugar and sulfuric acid. Several things tell you that a chemical reaction was taking place. Bubbles were forming and a gas was given off. The beaker became very, very hot, but most importantly, no substance formed. And the properties of those substances were going to be very different from how those substances started. So breaking and making bonds. This is just a visual to show you that a chemical reaction is basically breaking bonds to reform bonds. So in this particular example, we start off with two diatomic molecules, hydrogen gas and chlorine gas. They have H2 and Cl2, and what we are going to do is we're going to mix them together, rearrange them, give them different patterns, so the H is going to break away from the other H, and it's going to go ahead and pair with the chlorine. So we're going to make totally new bonds. A new substance is formed. We have hydrogen chloride or HCl. It's also known as hydrochloric acid. That's all what today's lesson is about. Feel free to ask any question regarding the lesson, and don't forget to answer the self-check question as well as the section review. Good luck. Goodbye.